Hello, my name is Suvendamika Satra. My PhD topic is on design and development of improved topologies for microgrid connected bidirectional converter with energy storage. Bidirectional converters are really essential for storage interface in microgrid as well as in electric vehicle. There are two broad categories of bidirectional converter. One is isolated, another is non-isolated. Isolated bidirectional converters have more number of active switches with necessary gate driver circuit as well as load dependent soft switching condition. This left a research gap for the development of non-isolated DC-DC converter, especially bidirectional stage. Storage voltage is of 24 to 48 volt and DC-link voltage of 380 to 400 volt. Therefore, greater than 10 voltage gain in boost stage as well as less than 0.1 gain at the bus stage is necessary for interfacing the DC-link voltage in the microgrid. There are several topologies published in the previous decade in this particular direction. However, the common problem is the high switch current stress, especially at low voltage side main switches. To solve this problem, in this work, there are two solutions has been proposed. One solution is to use LD-based network in series with the main switches to reduce the slope of the peak current. And the second solution is to apply half cycle based resonating branch to modify the current path to achieve the very less current stress at the low voltage side main switches. And this solution do not increase the RMS current of the main switches. Now LD-based network has main disadvantage of having this energy is being wasted in the diode, and therefore the voltage gain as well as efficiency is being reduced in this kind of solution. However, in solution 2 there is no decrement in the voltage gain as well as efficiency. Now applying this concept of half cycle based resonating branch in a non-isolated high gain bidirectional converter, DC-DC converter is being proposed in the second work of this thesis. This bidirectional converter is suitable because it can achieve zero voltage switching turn on, and it has efficiency more than 94%. It has more number of parallel paths, especially in the low voltage side, to distribute the current equally, and it has less number of less number of equipment, and as well less number of active switches, and as well as low voltage stress and the current stress. Improve the efficiency of the converter proposed using MOSFET, gallium nitride based switch is being used. EPC 2110 switch is being used here. The main problem is voltage ringing and false triggering on the top switch. To eliminate this, in this work, an LD based modified gallium FET driver is being proposed and implemented, which shows satisfactory result to minimize the voltage ringing as well as false triggering, especially at the top switches. And 1 to 1.5% efficiency improvement is also been recorded. In the fourth problem, it has been new circuit topology is being proposed. Generally, when storage interface is necessary, the ripple current at the input side should be very low. Interleaved structure is very much popular for that. At 0.5 duty ratio, interleaved structure can propose a zero input current ripple. However, it has in other duty ratio, it do not have that kind of property. In the current solution of non-symmetrical structure is being proposed, which has fairly constant input current ripple throughout all the duty ratio. And in the last work, we have found out what should be the value of input capacitor which is connected in the PV panel to extract the maximum power point tracking within simple P&O algorithm. The capacitor value selection is very much important since it reduces the system transient time, which is helpful for changeover to reduce the changeover time from buck stage to boost stage with system respectively with respect to system, and that can be found out both from grid side as well as from the source side using two-port network theorem. So all the research findings of this thesis work can be found out in the journal publications and also in the conference publications. Thank you for listening.